Hey everyone, my name is Joey Wilson and I am with CS for All Teachers, a project of the American Institute for Research. We are excited to have you here today for the webinar on classroom practices for modeling virtual reality. We just started recording it, so in case you have any colleagues or friends that can't make it today, then if you have any colleagues or friends that can't make it today, we will record it and we will post it onto the CS for All Teachers website and post it out onto Twitter as well. Let's see can everyone hear me? Can I just stop there and just ask because I had a question? Okay, I can see people in the chat said yes. Excellent. Okay, so with that, I will hand it over to your host for today, Donna St Germain. Throughout just as a few ground rules for this, feel free to jump into the chat if you have questions or comments or you have resources. In the last webinar that we had a ton of resources that came out of it, and we'd love to make sure that if you have any either thoughts or comments or resources, please feel free to share them. I'll also be monitoring the chat for questions, so then that at a time when our presenters aren't speaking, we can make sure that we get your questions answered. And so with that, I will hand it over to Donald.
Thank you, Joey, so much for the introduction. Once again, thank you for everybody who is joining us tonight. Truly appreciate you guys joining us this evening. And just to add on to that last part that Joey said, please share any resources, questions, comments, suggestions here. We'd more than appreciate it. I don't want to really think of us as experts, but more so we're facilitating and starting the conversation, and hopefully all of us can share our expertise or knowledge on this topic as we continue through this conversation. So tonight, once again, my name is Donna St Germain. I am currently a high school teacher in New York City, where I teach a mixture of ELA, Intro Computer Science courses, and AP CSP. I'm also one of the ambassadors for CS for All Teachers, CS in the Wild, and I'm also a TFA ECS Fellow alumnus and a CI CS Assessment Fellow. Joining us tonight, we have a couple great panelists who will be able to share some of their insights on best practices on implementing VR in the classroom. We have Jordan Badasantoso, founding CS teacher, Washington Leadership Academy. We also have Hassan Karuni, engineering manager, Facebook at Mod Labs. Unfortunately, Amy DeMarco was not able to join us tonight, but she did help us out tremendously in this process of putting this webinar together. So we will be sharing some of the resources that she shared as well. So to start us off, what is VR and AR, virtual reality, and augmented reality? What does it look like in the classroom? What issues may students and educators face if using these technological advancements in their classroom? These are some of the topics we discussed previously at our last webinar, and really thinking about what are the challenges individuals face, not only students, but educators trying to bring it into their classroom. So what we're going to try to do today for today's webinar is we're going to continue that conversation, but really look at some specific examples of what it may look like to implement and use virtual reality in the classroom and share some best practices and suggestions. So popularity of virtual reality, it seems like it's taking over, and everywhere you're seeing examples of it. There was a recent movie that just came out, Ready Player One, that was hugely successful, that focused on immersing people into a virtual reality world. We've also seen it at the Olympics, other sporting events, where for fans who aren't present in attendance, they're able to interact, review the content that occurred at these events using virtual reality. So it's spreading at a tremendous rate. And we really want to think about how can we use it not only as entertainment and fun, but have a better understanding of how can we create virtual reality experiences in and outside of the classroom. So for today, what we're going to look at, we're going to look at 4 different examples of how we can implement VR in the classroom. The 4 resources we're going to look at today are Panaform, the virtual reality curriculum provided by CodeHS, A-Frame, and Unity. The idea behind selecting these resources is that we want to be mindful of everybody where they're at, whether you're in elementary versus high school, whether you're familiar using virtual reality in your classroom or this is your first time. So we want to really show you guys different options to see what you guys may feel comfortable and hopefully say, hey, after this webinar, I think I'm confident in bringing this resource into my classroom. And once again, if you have any suggestions on something that's similar or another resource we could look into that others could look into as well, please share that resource so we can have access and share with everyone who is present, who is not present tonight. So what's going to happen for those 4 examples that I just displayed on the for you guys, we're going to pretty much go through these guiding questions to start the conversation for each one, just so we can think about it and how it may apply to our classrooms. And it will definitely open up the opportunity for other suggestions or other particular questions if it comes up. So the guiding questions are: what resources are needed to implement this example in the classroom? What type of hardware, software? What is the level of difficulty of implementation? How does this align to other CS concepts? And what are suggestions to modify, differentiate this resource into a classroom? So the first example that we're going to look at is that Panaform. And one suggestion that I always recommend as a best practice for an educator, if you're not sure how to do something, Google it, or in this situation, YouTube it. So in this situation, to start us off for tonight's presentation, we're going to actually look at a video that was created on YouTube on how to use it to give an idea of how we can implement it ourselves in our classrooms.
And we're about to just switch over to show the video, but for those of you who are calling in via a phone and are listening via audio via the phone, I'm putting in the link to this video onto here because you won't necessarily be able to hear the audio until you click on the link. So give me a second. The link is right there. I'm going to switch it over and start to play the video. And I'm going to let it buffer because the Adobe platform can be a little messy sometimes. And in a second, you should start to hear the video if you are connected for audio via the computer. If you're on the phone, click on the link and you can watch the video.
Let me introduce you to one of the easiest VR creation tools out there, and it's called Panaform. And I'm going to walk you through how to very quickly and easily set this up and use this tool. First, you want to start on a computer, and you want to go to the website, www.panaform.com. And when you get there, the first thing you want to do is get a grid. And what you're going to have to do is print this grid so that you can draw on it. So if you click on the grids option in the menu, there's a couple of different types of grids. I'm just going to go with the first one. And when you click it, it's going to ask you to download it. So you want to download that grid to your computer. And then once you have it downloaded, you're going to print it. Just print it on a standard 8.5 by 11 sheet of paper, very simple. And so I have an example here, print a piece of paper. And I've drawn a couple of different examples of how I'm considering using this with different classes. So chemical compounds there, maybe different animal cells and plant cells. Different examples here, maybe even sketching out some pictures. I was trying to do like a, like what does an animal cell look like?
So real quickly, for those of you who may be on your phone and not be able to see and hear the video, quickly just showing the outline and structure of Paniform and the process of printing out the design layout in which you're able to draw any type of illustration that will eventually be turned into a VR experience for the creator or anybody who's using it. So in this example, the individual drew a picture of an animal cell with an actual image of a dog connecting to the cell. And this is something that we're going to see in the next steps, how someone can actually take these drawings and illustrations and turn them into a VR experience.
From inside a dog kind of a thing. And even just your own sketches would be great for storytelling, right? Storytelling in VR. And once you have that picture set up and drawn on your paper, you're going to snap a photo of it. You get pretty close and take a picture. And then what you want to do is you want to crop that photo down around the boxes, like so. So you're going to crop it down around the grid, precisely like that. Then on your phone, you want to navigate over to the paniform.com website, and right on the home page there is an option to choose file. When you choose file, you can grab that cropped grid from your camera roll, like so. And when you do that, it's going to upload it into Paniform, and now you've got yourself a virtual reality experience created by yourself or your students. And you can also switch it over to cardboard mode or 3D VR mode by tapping the headset, and then you can physically move your device, pop it in a VR viewer, and you are good to go with some homemade, created, hand-drawn virtual reality experience. Let me introduce.
So like I mentioned earlier, the beauty is, especially as educators in the day of technology, if we're not sure how to use something, never be afraid to Google it, YouTube it, and see what is available there. So one thing that I love about Paniform, it's as you guys saw in the video, this is something that could easily be practiced and developed into the classroom at any age level. Paniform is available on pretty much most cell phone devices, and it really allows the creative juices to flow. So anyone can create any type of illustration. Maybe there's a storytelling project that's a focus for the curriculum at the moment, and they could use Paniform to display and create their VR experiences. There's not much cost besides having cell phones, so someone could use their own cell phone. Students could share the cell phone in the classroom, and then you would just have to get the VR headsets that are relatively cheap. Something like a Google Cardboard box would work, or any other one where they would just insert their cell phone. In regards to alignment to CS concepts, it's hinting at creativity, but it is lacking in regards to where students aren't programming or putting anything in regards to probably any algorithms or step-by-step process in order to create their virtual reality experience. But it can be applied to other subject areas, so maybe it might be a collaboration from a CS course with a history course or an art course, etc. So I'm just going to open this up right now to the panelists, and if you have any questions, feel free to type them in. Suggestions, thoughts on how could best implement Paniform into the classroom, any similarities of other resources that are available that could be used as well.
Hi, so I want to jump in here, and everyone in the chat, please type in a yes if you can hear me so that I know if I should keep going. But I think this is a really cool tool. I mentioned in the comments that I've seen something other than Paniform. It's called Vizor.io. That's Vizor.io. And it's a similar tool in the sense that you can build these sort of 3D and virtual environments online. What I think is really powerful for this, as you guys think about implementing it in your classrooms or whatever educational context you're in, is that this is a really cool type of activity because what the students are doing is they're getting hands-on with this stuff, and they're drawing something out and then all they have to do is take a picture on their phone, and they upload it to this web tool, and then they can use that web tool to actually see this environment that they quickly sketched out. So I think that this is a great tool to use as a motivator for further things that you would do with virtual reality in your classroom, and to get students having some of those hands-on experiences and more creative things that are more tangible. I obviously love computer science, engineering, and tech, but I definitely respect that using your hands is fun too. We all like that. So I think that that's one of the strengths here. And I don't have anything else to add. I think that this is a really cool one. I've run a ton of workshops with a similar type of tool, and it's fun to see people quickly just jot stuff down and then actually like see it on a web browser rather than have to use some of the other tools that we'll talk about later today. They're awesome too, but it takes a little bit longer to develop a first prototype and get that first quick experience. And that's all I have to add on this one. If anyone has questions, I'm happy to go deeper into, you know, how this works or some ways that you might facilitate it. Just let me know.
Yeah, I agree with you, Hassan. You made some really, great points, and I really think about a student who's either entering a CES course or is interested in the concept of computer science. This is a great way where they're not so focused on the screen and they're unplugged away to really get their creative juices flowing and think about what their layout is, what is the concept they're trying to put together, and then to see that get developed and illustrated in this VR experience in such a quick, short time frame is something that could be a great motivational boost for a student to say, hey, what else can I do into virtual reality? What might be the next step that I might consider to start off after, to continue after this? So this is a great thing that could be used for anybody who's your first time wanting to use VR in the classroom. And I know, Hassan, you mentioned the other example as well. And for someone who has already used VR already, this is going to be a great activity as well to get students away from the tech and just get them to get their creative juices flowing as well. So we don't have any other questions or comments about this. And if we don't have the time to answer your questions about Panaform, all of them at this moment, we'll definitely make sure to find an opportunity to come back to it a little bit later tonight during the Q&A section. So we're going to move on to our second.
Let me know if I can add in one more comment, or if you want to move on.
No, definitely.
Sure. So what I just wanted to say here that really this activity in the past I have used as a go-to get started with VR activity so many times. So Carol just asked, does a photo work, not a sketch? The answer is yes. You could take a 2D photo and you could put it on Panaform or something like Panaform. What Panaform is doing is it's taking that box that you see and it's kind of wrapping it onto a 360 sphere. So it has that 2D image, but you see those lines there because those are sort of guiding lines for how all of this is going to be projected into a 360 virtual environment. So you could actually just use a normal 2D image. It's just that when it gets stretched out, it's going to look weird and it's not going to make sense. So what's really cool about this is it's not just a great go-to like workshop or first activity, but also like I was just talking about and as it was motivated by Carol's question, this really helps students to start to see like how 360 photos work, how those grid lines in a 2D image gets wrapped into a 360 environment. I think there are some cool composition skills there and thinking about how to lay out the scene that they could think about. So that's all I'll jump in with on this. Happy to move on, but wanted to chime in with those final thoughts.
No, thank you for that, Hassan. That was very insightful and truly appreciate that additional input you were able to provide on this one. I do truly think that's important for us all to know and share. So what we're going to do now is we're going to move on to the second one. Our second example that we're going to be looking on tonight is coming from CodeHS, and this is their brand new virtual reality curriculum. One of the things I love about Code HS, I've used some of their curricula, other curricula as well, and they provide a lot of resources for teachers in regards to detailed lesson plans, solution guides, and they are always available to respond, support if needed. Usually turnaround time to get a response back is less than 48 hours, usually closer to 24 hours. So that's really cool about them. One thing that I'm going to show you guys right now, this is another video, but one thing that we've been working on at CS for All Teachers is trying to put video tutorials for you guys if for something you may be interested in using in the future. So what we're going to show you right now, we were able to actually partner with some of the curriculum developers at Code HS who put this curriculum together. They're giving you a step-by-step tour of what this curriculum looks like and what are some of the cool features that are available.
And this is Joey from CS for All Teachers. As once again, we're going to show a video. If you're dialing in via phone, I'm going to put the link into the chat right here. And please feel free to click on the link, and we will tell you which part of the video, because it's a 14-minute video, and we're going to show only pieces of this. But the entire video is in that link right there. And so, Donald, what part did you want me to start at again? At 4 minutes?
Yes.
Okay. I'll start at 3:57, and I'm going to let it buffer just for a second because the system's a little slow. And then you should start to hear it in a second. And Donald, feel free to take over when you need to.
Mobile devices, they can actually view this. This is just a web page that they would want to load, and then they could either just view it on their phones, or if they have a Google Cardboard, they can use that, one of those headset devices that a mobile device just plugs into. This is also something that they would make after the first lesson, just getting started. They learn about planes and spheres, and that's about it. So after the Getting Started module, they learn about advanced shapes. So beyond just the sphere and the plane, what can they do? They learn how to set the sky, they learn about cones, they learn about boxes, and they learn how to put texture on boxes. So this is an example program that they, this is actually an exercise in the course. So they make the Great Pyramids of Egypt. So they, you can see, are using cones. This cone has texture, so it actually looks like it's made out of sand bricks. So it looks like one of the pyramids. And again, this is all viewable. If they had any sort of VR headset or mobile device, they could view it.
So what you guys, if just saw, if you weren't able to see it, Code HS in their curriculum, one of the cool things I want to mention is they do recommend this curriculum for the age grade middle school through high school, 6 through 12. One of the things they suggest for some of the lessons that use some elements of geometry that might be more so recommended and tailored towards high school students. But one of the cool things about their curriculum is you can do it together collectively as a whole curriculum, or you can do them as individual lessons. So once again, this is a cool resource from Code HS. This is something you might say in your classroom, depending on your students. Hey, we might want to focus on short activity, a couple of them, or we want to make this a term-long or semester-long curriculum that we're going to develop from each stage to the next. So as you saw in the video, or if you didn't get to see it, quickly what they displayed was some of the layouts of the different options, as well as how students start from building shapes. So you went from building small circle shapes that built up to a snowman that eventually led to an example of students building the pyramids of Egypt. There are opportunities where it'll develop next to where students will get in towards animation and start creating images that are moving in a virtual reality experience. And then the next part that I'm going to show you guys right now is going to be an example of how students can use a 360 camera to bring in some additional real-world experiences into their examples.
Of just consuming something that somebody else has made. After interaction, we have students learn how to put 360-degree images, so images made with the 360 cameras, and how to bring those into their VR worlds. And this is actually a really good, if you're doing a standalone lesson and you don't have time for the full course, this is a pretty good way for students to make something that looks really cool, and it's relatively easy because it doesn't involve them setting things in a 3D space, so they don't need to know the coordinate system as much. So they learn how to source the 360-degree images, because there are some websites where people put up 360 images for people to use, and we learn how to bring them into our virtual reality world. So this is an example 360-degree image that was brought into a VR. You can see we can look all around, and again, this would be really cool if this.
So minor technical difficulties with the buffering. Just quickly, what you guys just saw was an example of students using some 360 clips that were available via A-Frame to bring into the curriculum, where they're able to create a 360 VR experience. If you have your own 360 camera, then this is something you could maybe import and create your own examples. Maybe you do a day in the life at your school as an example activity, but there are a lot of available resources and images already available online with A-Frame that you can implement as well for free. And one of the things that I love about this is, if you see on the screen, or if you can as well, that students are seeing their programming and how their programming is leading to the virtual reality experience. I know it was mentioned before, the idea that sometimes virtual reality just might be seen as a gimmick for fun, but what are students learning from it? So I think this is a cool alignment to the CS concepts, where students are developing their programming skills in this particular situation with HTML, and they're seeing how the development of their code creates to leads to the development of this virtual reality experience for everybody. And then I'm going to open it up right now, like last time, just to the panelists. And then we're going to try to answer some of the questions too. Any suggestions, thoughts, feedback? I saw one question about the cost. Usually, from my experience, and I'll double check to make sure to get the correct answer to you guys, is that the curriculums are usually free on CodeHS, but the level of support with the detailed guides are usually what you have to pay for. This is a new curriculum that they just created and just released this spring. So I'm definitely, they will be, if we reach out to them, I definitely feel like they'll be able to support and provide guidance on how to implement, and at the same time, take any feedback and suggestions, especially if people are interested in developing it. But from my experience, I've used them over the past 2 years, and they've been very helpful. And I think it just works well for students who might be present in the classroom, or for students who might be absent, to find a way that's very detailed on what did they miss and how can they catch up. So right now, I'm just going to open it up to any of the panelists, any suggestions, thoughts on what we just saw for the example number 2.
Hi everyone, I'm Hassan. I was talking before, and Joey gave me the reminder to actually introduce myself this time, so thanks Joey. You guys will hear from me later on some more content. I think A-Frame is really exciting, and it's awesome to see what CodeHS has done with this. Actually, it's really interesting that I think about a year ago we were working with them to try and develop an A-Frame content or offering. Maybe it was a bit longer, so it's cool to see how far it has come. A-Frame, I think it is a really cool resource that you can be using in your classes. One of the great benefits of it is that it doesn't require very complicated hardware. You don't need a headset. You don't need a fancy computer, you should be able to use A-Frame with something as basic and accessible as a Chromebook, because the experiences that you build, there's a browser version first, so you can just look at them in a 2D window or on your laptop. But if you have a VR headset connected to your laptop, or if you are in a VR headset and visiting the web page inside of that VR headset, then you click a button to go into VR mode, and then you go from the 2D interactive view to actually a more of a VR 360 and three-dimensional view. So I think that's what makes this a really good fit for classrooms. Another one has to do with the level of difficulty of implementing it. And we've already been talking about in the chat that if you have like students that are already interested in HTML, CSS, or JavaScript, it's a pretty easy jump to go over to A-Frame. If they don't have any experience with web development before, it might be a little tricky, but I still think that there are huge wins around just the fact that you can run this in any browser and on many types of laptops. These are also really cool because they're easy experiences to share. You usually just need a link. That's one of the big promises of web VR, which is generally the area that A-Frame falls into. Other tools that you could look into if you're interested in these browser-based accessible VR experiences are Visor, the thing that we talked about before. I think it was called I forgot the name, Panaform. Also React VR is another one. All of those are broadly referred to as web VR experiences, and I think that they're great. In terms of alignment to other CS concepts, there's a lot of alignment. I mean, like we were just talking about, they use HTML, CSS, JavaScript, so those are programming tools that you'll use for other skills. And also, a lot of the paradigms and the concepts that you see when you're working with A-Frame, React VR, or anything else, they translate very well to the types of VR that are not web VR. And that actually relates to a question that just got asked in the chat. Somebody asked web VR versus what else? And that's a really good question. So I've talked about how A-Frame and React VR, Visor, Panaform, those are web VR, but what is there that's not web VR? Well, there's PC VR or mobile VR. PC VR is when you build an application that someone can download on their computer, and then they plug in their headset to the computer, and they can use that application without any web access. So think about it like, running Excel or any other app on your computer. Basically, you're building things that people install onto their computer and then they use. Mobile VR is something that's similar, but instead of downloading it to a computer, you download it to an iPhone or an Android phone, and then somebody clicks a button on that to open the application, just like any other application, and then you put that into a VR headset, and you can jump into that experience. So you have web VR, you have PC VR, and you have mobile VR, and sometimes they kind of intermix too. So thanks for the question. And that's all I have to add for this one, at least for now. Maybe someone will say something and then I could chime in more.
Thanks, Hassan. Once again, I'm trying to look at some of the responses that people are and questions people are bringing up. I know from some of the experiences in the past, I don't always have enough VR headsets as well. But I think some of the ideas, which can be really cool, especially with the two examples we've seen, Panaform and Virtual Code HS's curriculum, is that this could be something where students work together to create and develop their projects as teams, partners, paired programming, or in smaller groups. And then this could be something of a gallery walk or a virtual reality walk, where students can come together and rotate and share their projects and immerse in the experience of what their classmates were able to create. So right now, to continue with this conversation of web VR and using A-Frame, which is the focus of the virtual reality curriculum of Code HS, we're going to continue to talk about A-Frame and what it has to offer. So I'm going to segue right now to one of our panelists, Jordan, who's going to speak a little bit more about how you can use A-Frame in your classroom.
Hey, can you guys hear me? Oops, yep, give me 1 second. Let's try this now. All right. Okay, so I'm going to screen share, and hopefully you guys can see this. Share my screen. Give me 1 second while it loads. Okay, so A-Frame, as everyone has said, is a pretty good tool for students to get and dabble with VR. And I teach, by the way, my name is Jordan. I teach computer science in DC at a school where every kid takes computer science in the building. And we're very, big on this movement of CS for all and exposing kids to emerging technologies, VR being one of them. All of our kids have Chromebooks, so there's a hardware limitation for us when it comes to like exposing kids to VR stuff. And that's how I found WebVR. So once kids learn how to use some of this stuff, whether it be CodeHS or some other way, I want them to be able to like load this on their phones, but then also like I'm going to show you a little cheating way of like how to make it look like an app on your phone. And so I use a web editor called Thimble. This is by Mozilla. And I teach like intro web development with this because like, you can add files here, like a JavaScript file, and it does all those things, which is very, very neat. And then it's as simple as hitting this publish button here at the top of the screen, and it'll publish it to a website that a kid can visit on their phone. And when they do, hopefully this will work. I have my phone here. Oh, can you guys see that? Oh, maybe not. This should be my phone. Can you guys confirm that you see that? Because on my preview, it doesn't show. Donald or Joey.
Yeah, it just shows up as for me, as some hatches.
Okay, yeah, so that's supposed to be my phone, but I guess it doesn't work on screen sharing. But I guess what you could do, and some of you might be familiar with this, is if you go to a website on your iPhone or Android and you go to settings and then you add to home screen, it'll create it as a nice little link on your mobile phone, and it almost looks like you've deployed an app. The one tricky thing about using something like this is that when you create and you publish it to the web, it's got this button called a remix button, which is kind of nice if you want kids to like share their projects and like edit them. But when you're actually on your phone and you put it in like the cardboard mode, that remix button is floating there. So you have to, I just went on GitHub and I reached out to some people. There's this nice little CSS code in here for just like Thimble projects where you can hide that. I created a bit.ly link if you guys want, and I'll drop it in the chat so that all you have to do is hit remix and then look at I commented it out so you can actually hit remix and you can see that there. And so that's really nice. The other development environment, so you'll see how this one doesn't have that remix button here at the top. The other web development or IDE that I like to use is Cloud9, if you haven't heard it. This is more of a realistic type environment that someone might develop in. And I like this because then you could start installing things like React or Node, and that's a little bit more professional in terms of getting things a little bit more advanced than just A-Frame, and that's really nice. And if you know how to publish your like repository to GitHub, all you have to do is once your code is uploaded here, you can go to settings, and then you scroll down, and then you just publish to GitHub pages, and then it creates this nice little link where you click it, and then it actually takes you to your project that's loaded. And so again, you're doing the same things here, just like you can slice it different ways depending on your students' interests and their level of understanding. And you can click these, and it's here, and you can go back and things like that. And so,
Jordan, can you put that link in the chat so that people can see it right now?
And you feel free to like go up here and visit this site, and I'll drop that in the chat as well, and view source, and you could take a look at everything that's in here. And so that's really all I have. I mean, CodeHS wasn't around when I started, or at least their A-Frame course wasn't around when I started with students. But now, as we get more students like folded into this, I definitely point them to CodeHS because it's a pretty good scaffolded way to get them into A-Frame. That's all I have, Donald.
Thank you, Jordan. I loved the collaboration that's available. I think that's one thing that I've been really trying to push for my students to understand, especially as they dive into more CS concepts and start to create larger projects. They don't always have to start from scratch. We have so many resources that are available on the internet. So sometimes it might be helpful to look and see what somebody else has created and thinking about how can you remix it and put your own little twist on it before starting on your own and creating a project. I know several teachers, Jordan and myself included, just had some of our students wrapping up the performance task for the AP Computer Science Principal course. And that type of concept of, how can I look in and see someone else's code, their programming, and figuring out how can I add a twist to it, how can I understand what they're doing and add my own layer to it, is something that could really be beneficial for other students. Jordan, if you could share from your input, how would you recommend differentiating using something like this in the classroom?
Do you mean like differentiating groups? Sorry, I'm like doing a phone and web call. Do you mean differentiating in the sense of like scaffolding with these tools, or elaborate for me?
Scaffolding with those tools, yes. I know you said at your school, all students are provided opportunity to take a CS course. But if it's a situation where you might have some students who have had the opportunity and some who are not, and they're in the course for the first time, how would you manage those two different groups of students together in activities using A-Frame?
So just as a coding practice in general, it's not like college where you took a lecture class and then you had a lab class where you like started building. You can't really do that in the K-12 setting, at least not for us. And so what I found when I started teaching like coding stuff, kids would get lost, or like they would have some syntax errors, and it would stall the whole class, or the student would be disengaged as I said, hey, just wait and I'll come help you. So I just did a lot of just like video recording ahead of time, and then having kids watch a code along. So that's one way to scaffold, because again, kids can pause and rewind, and if kids have a question, everyone else is still watching the video. But then, yeah, just purposely scaffolding what you want a student to do. So I might show an end product, like, hey, here's how I import a 360 image into A-Frame. I'll show you how to do it, then you pick a 360 image from this Google Drive that I found for you, all these pictures, and you try it. And then now go find your own image somewhere on Google Street View or something like that. I don't have the link to it now, but there's a pretty cool app out there where you can download 360 images off Google Street View. So you literally have like an endless repository of 360 images at your disposal to like import into A-Frame.
Awesome. Thank you for that. And right now, ladies and gentlemen, we have one more example that we're going to look at, and then we're going to open it up to more Q&A from the audience. We're going to pass it over to Hassan right now, and he's going to talk a little bit about Unity and how Unity can be used to create VR experiences in your classroom.
Awesome. So I could use some help. I'm not sure the best way to share my screen, or Donald, if you can force it to share my screen. I think, is that working?
Yep.
Okay, great. So I just wanted to give a quick intro. It's great to be here. My name is Hassan. I work at Facebook on a team named EdMod Labs. EdMod is short for Education Modernization, and we work with a ton of high schools, mostly in Arkansas and Washington, but also some others, on really trying to help educators, so mostly teachers in high schools, and students to start working with cutting-edge technology. So that might be chatbots, AI, VR, AR, and so on. I personally love VR and AR. I think that the industries are incredibly exciting, and that's why I absolutely love to share any of these resources. My background is in development and engineering, so I know a lot of different resources, and I'm happy to talk about them. I also want to share that there was a huge announcement today. I don't know if any of you were following F8 which is Facebook's developer conference, but we announced a new headset that is being released for everybody to use. It's called an Oculus Go. It retails at, I think it's $200 or $250, which is a lot cheaper than a lot of the higher-end headsets out there. But the main reason why I'm really excited about this in the context of education is that this is a standalone device. You don't need to connect it to a computer. You don't need to connect it to a smartphone or anything like that. And I'm mentioning this here because something that we're trying to do with this is get some teachers to give us feedback on their past experiences with VR and let us know if they're interested in trying out the Oculus Go. So I just wanted to put this here, and there's also my contact information. If any of you guys tried VR and if you're excited about talking about the Go and upcoming technologies, please reach out. We'd love to talk with you. So the pitch is over now. Hopefully you guys didn't see that as too much sales. I'm sincerely actually just trying to help everybody understand the technology, and I think that this is a cool one that's coming up. So we'll talk about what I will go through. The first is I have some big questions that I wanted to ask everybody. Then I want to do a quick Unity model, and then also based on the questions and your answers, maybe we'll have some time to talk about your specific interests. So the questions that I have for everybody is I was hoping that you could tell me two things in the chat, and then if we have time, I can provide some more specific input beyond just talking about Unity and help you to understand what you might be able to do in your classroom. So the first question that I have is I want to know what's the hardest material or common core area that you have to teach every year. And then also let me know what equipment you have access to, whether that's Chromebooks, Macs, Windows, computers, iPhones, Androids, or something else. If you let me know that in the chat, then I can try to help you out with more things that may work in your classroom. So I'll leave that for now, and let's actually jump into Unity. So I want to do a quick check, or can you guys confirm that you can still hear me before I dive into this? Not hearing anybody right now. Let me see if
we can hear you.
Yes, we can hear you.
Cool. Great. Just wanted to double check. I know I'm launching into a lot of different things, so I wanted to get the go-ahead. So I'm a huge fan of Unity for AR and VR development. The reason why is that a lot of the industry is using Unity, and I love that if you can actually use Unity on the computers that you have, unfortunately it won't work on a Chromebook, but it will work on a lot of other things. A great benefit here is that you can use Unity to build so many different things. Mobile apps, you can use it to build web VR experiences, as we talked about before. You can use it for PC VR. You can also use it for mobile games, but also for non-games, so simulations and things like that. I just want to show you a quick example of how you could get started with Unity. So I downloaded Unity. You can find it online. And I'm going to hit New to create a new project. I'll call it CS for All. And this is going to load up Unity. It takes a little bit of a while to start up, but what I want to show you guys is that it's really easy to add in an example with just some basic physics effects. And then after that, you can actually use programming to start adding some more dynamic things into your project. Also in the background, you guys are seeing my weird wallpaper. I'm a big fan of comic books. I don't know if any of you have checked out The Sandman. But that's what that was. So that's why that looked a little weird for a while. It's a great comic book if you want to check it out. So now I'm in Unity. There's a bunch of different panes here and different panels. I won't go into the details on those. They're pretty simple once you read a basic guide, but I do want to show you how easy it is to start off with those physics effects. So what I'm going to do first is I'm going to create just a basic plane. So I'm going to go to, I'm clicking on Control and just click on my mouse right now. I'm going to 3D Object, and I've added in a plane here, and I can move this around just by clicking and dragging. And I can add a ton of different types of other objects too. So again, Control and click. You can also just select Create in the top left here. And if I go to 3D Object, that's why I added the plane. But I can also add other things. So I could add a sphere, and now I have a sphere there. And you see that there's also a lighting model. Let's see, I think I just got a message from Daniel. Let's see, is everything still going okay on the stream?
can see everything. Can other people in the chat box just confirm?
Great. Then I will keep going. Looking like stuff is fine.
Great.
So, I mean, there what I've shown so far is just opening up Unity, and I'm adding 2 basic objects. So now when I hit play, that actually starts like a simulation of this project. And this will be, I mean, nothing actually happened there. It's just showing me this view of the 2 objects in my scene. And what I'm going to do now is I'm going to add something that starts to model physics on this ball and on that plane. So if I go over to Add Component, I can add a rigid body. And a rigid body in Unity is what you add to something when you want to start simulating physics effects. So now I've added that rigid body to this sphere, and when I hit play, it should actually fall onto the sphere. So that's just showing something really basic. Let me add one more thing. I think that something that can be pretty cool to do is start making like different types of physics objects in Unity. So I'm going to go over here to Assets, and again, I'm Control and clicking, going to Create, and then somewhere here it says Physics Material. There it is. I'll call this Bouncy Material, and then on my sphere, if I just click and drag that onto the material, the physics material slot on this this sphere, then now when I hit play, you'll see that this thing actually bounces, or it should bounce. There might be a little bit of a lag because my computer is trying to stream right now. Oh, it's not bouncing. So let me make one edit to this. So I'm going to up to the bounciness. I feel like there's a true physics term for that, but in Unity it's just called bounciness. And this actually should bounce this time. So that was really simple, but what I'm trying to show here as a proof of concept is that you really, to start getting physics simulations, it's not that hard in Unity. And I think that that's really cool because you can kind of change the conversation that you have with your students. You know, they can create something without using any code first, and then they can actually start adding code once they've created these physics simulations. And I think this is a really fun way to introduce computer science in VR. Start with something that is pretty easy and visual and physics-based that lets them run simulations. And then when they get more excited about Unity, then you can start introducing some VR components. So I went through a really quick whirlwind here. I didn't even talk about what all of these different panels are. And the reason for that is that a lot of this stuff is actually pretty easy to find online. I know some of you might be thinking, oh, like I came for this and the guy's just going to tell us to Google. That's lame. But the truth is that for Unity, there are so many resources that honestly your best bet is to search Google. If you just type in Unity intro, I would really recommend this roll a ball tutorial on the difficulties beginner, and it walks you through all of the basics to create a simple game in Unity where you roll a ball around. You can also type in Unity Intro VR, and they have other resources on getting started with VR development. So I could have went into more detail on the exact details of the editor, but what I would rather do is take questions that you guys have, because really for Unity, the best resources that you're going to find, they're already online. So rather than doing them live, I think you guys could check out what you find out if you type in Unity Intro or Unity Intro VR. So that's actually everything that I have planned for now. I can check out the chat to see if there are any questions, or Donald and Joy, if any popped up, I'd be happy to answer them.
One thing I want to point out, I saw some of the questions, and I posed the question too, how long are the courses individuals are teaching? To my recollection, I haven't heard of anyone doing a year-long VR or even a semester-long VR course. Sometimes it's often used as like something we can quickly do to entertain and engage students. But I think this is something where we can really think about how we pacing and developing our CS curriculums at our schools, where this might be the situation where we could invest more time in developing an A-frame curriculum or one focused strictly on Unity. I've also attended hackathons where you had students competing against each other, developing the understanding of CS concepts and teams, where some students were using Unity versus other students who were using Scratch. So I think it's really key that we think about how we're teaching our students these concepts, how they're developing it, to see then how can they really apply it into a situation. So at this moment, I don't know if any other panelist has any other question. I mean, any thoughts, tips, suggestions. I think Hassan, that was a great what you showed for Unity. I know it mentioned there were some things we had to think about in regards to resources, hardware that we would need. I know a lot of schools, at least in the New York City area, have been pushing a lot of Chromebooks, which are great. But this might be something, if you're trying to use Unity, you have to go with the understanding that they do not apply work with Chromebooks. So right now, what we can do is no, continue.
I just wanted to jump in. I got a chance to review the chat, and a lot of the questions that popped up were, Unity or Unreal, Unity or WebVR. And I think that you're really getting on the right point there, Donald. Of if you guys are interested, or if you have Chromebooks, then I would definitely recommend the WebVR. So that's A-Frame, React VR, Panaform, and so on. If you have Macs or desktops or really anything that's not a Chromebook, because Chromebooks are not built to support graphics applications like Unity, then it's a tougher decision whether or not you want to go with WebVR or Unity and Unreal. I think that a lot of it relates to, are you excited about teaching your students about web development, or are you more excited about kind of app and game development? App and game development, I think Unity will be more fruitful. It's also what people are using to develop high-end AR and VR experiences. You have definitely WebVR being used in industry, but it is not being as used as much as like Unity and Unreal for PC and mobile VR. And then the last question that I saw was Unity or Unreal. That one is really a matter of preference. I would recommend checking out both, and I would only strongly recommend Unreal if you're confident that you have like pretty good laptops. So I mean, like, it's not MacBook Airs, but like a MacBook Pro, or like a mid-tier type of laptop, because I have seen in the past that Unreal can struggle to perform on some of the more standard or more basic laptops. So that's just my 2 cents there. If you're stuck to Chromebooks, then WebVR. If you have more than Chromebooks, then it becomes a matter of preference between WebVR and then between Unity and Unreal. It really depends on what you like better.
Thank you, everyone. Thank you, Hassan, for some great points. We want to be respectful to everybody's time and for the commitment that we ask for you. We'll definitely make sure we're going to gather all the information. If any questions we didn't get to, we'll have an opportunity to try to continue this conversation on the CS for All Teachers platform. Real quickly, I just wanted to give each panelist an opportunity just to give their final thoughts and recommendations before we wrap up this great webinar we had tonight. So I can kick us off. with some of the final thoughts. My final thoughts for everyone is definitely do not be afraid to take a risk in exploring the opportunities that are available. I know I was at that position when I first thought about using virtual reality in the classroom, was just like, hey, let my students play around with the headsets, and at least they're seeing the cool opportunities they could do, have fun with it. But a takeaway that I could take from tonight, there are different ways where as a first-time user of VR or an experienced individual, I can see different ways I can have my students create, develop, and then still interact and have fun with virtual reality. So definitely do not be afraid. There's definitely a community that is here, and if not, when we can develop, that will support us in using virtual reality in the classroom.
I don't have too much to say other than, I mean, it's comes down to the context of your students and the hardware that you have. Again, yeah, for us, we have mostly Chromebooks. We've got a couple MacBook Pros that we're like dabbling with Unity in the last couple of weeks. And so hopefully we can share some resources amongst each other about like what a semester long course would look like. And so we can get with Donald about that conversation, because I'm really interested in that too. But yeah, for us, given the context of our school and where kids are coming in at in terms of their knowledge, like we don't have a feeder middle school, so we've got kids coming from 37 middle schools this incoming class. It's just as big next year. So like kids come with all sorts of information. So like, you know, trying to scale up for our more accelerated kids who have seen some computer science before, and then, you know, kids who still type with 2 fingers. You know, it comes down to like, you know, context of what you're teaching. And so I think both Unity and A-Framer are good places to experiment with like what kids respond to.
Yeah, I could jump in. But I think it just got unmuted, so I could jump in. I think that, you know, the stuff that has been shown today is really cool to see, and I want to thank everybody. I mean, it's so invigorating to see, you know, so many people caring about getting this in the hands of like aspiring builders and students that want to get started. You know, here at Facebook, you know, we're building this stuff and we're trying to get people to use it and learn what's most valuable, but you guys are actually the people that are in the classrooms and making this possible. I think the stuff that Donald and Jordan shared, definitely check those out. So Panaform is really cool, and you may have missed it, but what Jordan talked about with Thimble and letting students like remix projects, I think that's something that you can do that's uniquely just accessible if you end up using A-Frame or React. So I definitely recommend checking out those. And then if you want something that is a little more industry aligned, then I would check out Unity. And I think that, you know, regardless of what you do, present it as something that's rapidly developing in an industry where there's a lot to learn, rather than decided on rules and the way things are. I think that if you present it as something that your students can pioneer and understand that you guys are pioneers too, then I think that's a way to get everyone excited about it. So that's my final thoughts on this all.
Thank you to all the panelists. Thank you for everybody in the audience for attending. As you see on the screen, there's a list of suggested resources. We're going to compile everything that was sent out today, and we're going to make sure to post it via a blog post on csforallteachers.org. So make sure you guys check it out, and definitely log in, create an account if you haven't already, because once again, we can continue this conversation and continue to share resources with one another. So on behalf of my panelists, CS for All Teachers, I want to thank everybody for coming out tonight, and stay tuned for more information and more events from CS for All Teachers. Thank you guys. Have a good night.
Thank you, everyone. And this is Joey. Please feel free to take the survey that will pop up. I put a link in the chat. I also just posted a link to where the recording will be. And I hope you all have a wonderful evening, and thank you for attending. Take care.